In this lecture, we will going to talk about the universal gates.
So we will be talking about the universal gates. Universal gate. So generally, when we are talking about the universal gate, we have got two gates. So we have got a NAND and NOR. So why we are saying it as a universal gate? Because whenever we are forming the gates, like we have to perform the AND operation, we have to perform the OR operations, we have to perform the NOT operation, that is also known as the inverter. Okay, NOT means we are using it as an inverter. So we are performing even NOR operation. So with the help of a NAND, we can design the inverter, that is your NOT operation. We can design your NAND gate, we can design your OR gate, and even we can design the another universal gate, that is a NOR gate. Similarly, we can say with the help of a NOR gate, we can implement the inverters, we can implement the AND gates, we can implement the OR gates, and even we can implement the NAND gates. So what I can say, that with the help of this, what we can do, we can implement inverter, okay, AND gate, OR gate, and even NOR gate. Similarly, with the help of this, I can use inverter, I can use it as an inverter, AND gate, OR gate, and even I can design the NAND gate. So let me take one example, and we will going to take an example with the help of a, let's say, we will be using the NAND gate. So we will be using the NAND gate as a universal logic element. So let's take an example, NAND gate as a universal logic element. So if I want to design, let's say I want to design the inverter. Okay, so let's say if I have a NAND gate. Okay, so in this NAND gate, we are talking about the 2-input NAND gate only. Okay, we have got a 2-input NAND gate. So what we can do, we can short the 2 inputs. So this is my NAND gate. So what equivalent I want? I want the output should be like this. If I am having A, I should have a A bar. This is your requirement. So what you can do, you can simply short these two terminal, and you can apply the A here. And if you apply the property of this NAND gate, okay, so what you will be getting? You will be getting only the single input here. So what you will be getting? You will be getting the A bar here. Is it clear? So let me use another one. Let's say if we want to make AND gate. So let's say if I want to make a AND gate. So my output should be in the form of this. I should have a B. I should have a output AB. This is my requirement. So how I can get? Okay. So first, from this picture, let me go into the reverse direction. Okay. So what I require, I would require this AB. Okay. But what will be my output from the NAND gate? If I am using the 2-input NAND gate, what will be my output? My output will be, if I am using my NAND gate, AB bar, yes. So my output will be AB bar. Okay. And what I have to do, I want to remove this AB bar. Okay. So what I have to do, I have to AB bar, I have to make it again complement. NOT gate, we cannot use the NOT gate. So what we can do is that just follow this instruction, and then you will going to see that we have got this AB. This is my A and this is my B. So what I am getting here, I am getting the AB bar. So what we can do, we can use this as again a short circuit. We can use it as we can have a 2 terminal gate. We can short it like this, and what we can do, we can get a AB bar ka whole bar. So this will become your AB. Is it clear? Take the third example. Okay. Now if I want to design the AND gate, AND gate we have designed. Now we want to design the OR gate. Okay. So how I can design? I know my OR gate will be like this. This is my AB, and I will be getting my A plus B. So now the question arises that how I can get A plus B. Okay. So can you tell me? See, again, follow the same instruction which I have shown you in the previous slide. for obtaining the AND gate, just follow this rule only. So let's say we have got this A. So what we can do, we can short two AND gates. So what we can do, we can have this A bar, and from here we can have a B bar, because from the AND gate what we will be getting, for the NAND gate we will be getting the output in the form of a bar only. So we will be getting a bar, B bar, and if I apply, I will be getting the output like this, A bar, B bar. Okay, and then I apply a bar. So can I apply a De Morgan's on this? So what will be this? A bar plus B bar. So this will be A plus B. Is it clear? So let me draw it. So what I can do is that I can draw a circle like this. I have a two input, so I can short it. So let's say this is my A. I will be getting a A bar here. I have a B. I will be getting a B bar here. Then what I will do, I will going to apply this. I will be getting the A bar dot B bar whole bar. Is it clear? So what will be my answer? My answer will be equal to A plus B. Now if I ask you, now implement NOR circuit. NOR circuit. What is the NOR circuit? A plus B whole bar. So NOR will be like this, A, B, and we will be getting A plus B whole bar. How you will going to design this? You can see that we have already obtained this A plus B. Okay, we have already obtained this A plus B here. What we required? We only required to make it as a bar. We have to make it as a bar only. So what will be the circuit? The circuit will be going to be same. We have a circuit like this. So let's say this is my A bar. Then we have got a B bar. B bar. Then we will be having a circuit like this. A dot B whole bar. So this was your equal to A plus B. Okay. And then what do you have to do? You have to short it again. What do you have to do? You have to short it again. So what will you be getting? You will be getting the output A plus B whole bar. Is it clear? Okay. So let me see. If I go here, how many AND gate I required here? I required only one AND gate. For this, how many AND gate I required to make the AND gate? 2. Okay. Here, how many I required? 1, 2, 3. Here, how many I required? 1, 2, 3, 4. Is it clear? So you can see that even we can design the XOR gate, we can design the XNOR gate from here. You are getting this? So you can see that how many logic gates required. So I am writing here. So I am writing here logic. Where the logic gate you want to design. Okay. And if I write number of NAND gate. Okay. And here I will going to write number of NOR gate. So you have seen that we are starting from the NOT gate. We are using the NOT gate. First we have designed the NOT gate. Then we have designed the AND gate. Then we have designed the OR gate. And then we will going to design XOR gate. Okay, if you want, you can just practice. Then we have got a XNOR gate. So why I have taken the example of NAND? So you have to just follow this table, that the number of gate required for NOT is 1, 2, 3, 4, 5. Okay, and just reverse this order. You know, in this NOT will going to remain the NOT only in the NOR also. Okay, this will going to remain the same only. So this will be 1 only. This 2 will going to be interchanged. So this will become a 3, and 2. This will going to be interchanged. So this will become 5 and 4. So this is how you will going to see. So thank you everyone.